Hey guys, what's up? My name is Waleed. Some of my teammates, Gurnur, Soham Day, and Ryan Marie, we're all part of the College of Engineering. We're all studying mechanical engineering. And I'll be presenting about our project, which is electric skis. It's literally what it sounds like, cross-country skis, but electrified. I'll go into that in a bit. So some introduction and context. The official name of our team is Frigid Dynamics, which is in light of our product, electric skis. It's exactly what you think, as I mentioned earlier. Just think about how an e-bike is different from an ordinary bike. The same exact thing. Keep that in mind and apply that to a cross-country ski, and then an electric cross-country ski. And yeah, I would like to give a huge shout out to Professor William Hauser, Professor Gutierrez, BU alum Nicholas Chow, for their advice, their support, their guidance along the way. We found ourselves often in unknown territory, and as a result, without their support and guidance, it would have been very difficult. So some current issues that we have with snow travel. So during winter months, snow limits mobility for a significant portion of cold regions, and this problem is quite prevalent in older or less able communities. On top of that, it also exists on days where snow happens or the terrain seems to be icy as well. And it's difficult for some people to go out traveling, whether they need to go buy some stuff from the nearby markets, or if they need to go to work. It just becomes difficult overall, right? And so thinking about these problems and thinking about what's there in the market, we're thinking about what the pros and cons were for different different solutions out there. And we realized that current solutions fail to package relief, convenience, and cost effectiveness. And so how we were trying to go about things is to come up with a product, electric skis, such that it provides relief in a convenient and cost-effective manner. And the solution, which is, again, electric skis, it could be used recreationally, or you could just travel with it and just have fun. And so there are a few important things that we need to keep in mind, especially when approaching these product drivers. One thing being affordability. We need to make sure that it's not super expensive, that it's available and accessible to people out there in general. It shouldn't be a luxury, right? And so it could be used recreationally, or just, if people want to actually get from place A to place B. It's completely up to them. The second objective that we had is making sure that the speeds are customizable, right? That people are able to control the speeds with the remote button. They're able to cruise control, they're able to brake, and that they also have the ability to use the ski as a normal ski by not activating the electrical component. And so the user has the ability to increment the speeds or to decrease it in a safe and efficient manner. And on top of that, we also want to make sure that the product is as compact and as lightweight as possible. And we actually tested the product with using different weights to see what would be the best arrangement. And if you look in the image on the right over here, or on the left, you can see that this is our initial understanding of how the product should be, where we distribute the weight behind the boot and in front of the boot. And so when we tested this by using different weights, on here we realized that this arrangement will be quite inconvenient for the user. It makes it much harder to turn. And so what we decided to do was to move all the weight to the back, right? And the weight's around like 10 pounds or so. And interestingly enough, it actually helps you turn a lot better, right? And so yeah, that was our initial CAD of our final product. And so when we did that test, it really showed us what is the optimal way to go in terms of distributing the weight. And then in terms of the speed, we wanted to make a limit for the speed, which is around 16 miles per hour. The reason for that is because in theory, the motor that we have, the device can go at around 32 miles per hour, and that is extremely dangerous. In the beginning phase of the project, the motor was just uncontrollable, and so you need to make sure that safety is our utmost priority and that everyone's safe, especially when using this. And so that's what we capped it at this speed. And then another objective is to make sure that we have a range of 2 miles per battery charge, because the reality is that, people are having fun, they're using this device. We don't want to kill the fun for them, right? I'm sure that many of us have had phones or devices where the battery just constantly dies. It really kills the experience, right? It's not as effective or fun. And so we took that into consideration, and we decided to stick with the 2 miles range, which is a typical distance, especially when it comes to cross-country skiing. And then another objective that we were trying to hit was regenerative braking. And so just to illustrate what that is, what happens is instead of the motor driving the wheels, we have the motor driving the motor. The wheels driving the motor, And so what you're essentially doing is you're putting energy into the motor. And so you're just being a lot more efficient when it comes to energy. So this is the current state of the product. Let's see if this video could be played. I guess not. But pretty much just to give an overall view of like what happens in this video is pretty much you have the orange device. It's a motor and it's attached to pulleys in the back. And so when you press a button, what happens is the pulley is turned inside a tread and it starts going like a snowmobile. And that's just a brief overview of how this device would work. On the next slide, I'll give more of a detailed breakdown as well. So over here, you have different components of the device, right? You have the motor controller on the very left. That's connected with the red and black wires. And then that's connected to the motor, which is which is labeled here. And then the motor is ultimately the one that's driving the whole tread system. And then you have the treads, which is a belt, and within that belt we have two wheels. It's very similar to how a snowmobile operates. And we decided to see how a snowmobile operates and really minimize that in terms of scale and integrate that into our device, forming an electric cross-country ski. On the top, you have an enclosure for the battery, and so there's no concern here because the battery does not really have much moving parts. So there's no concern about whether or not the enclosure will be torn apart or sheared in any way. If anything, it provides protection to the battery and also provides a safe home to stay in. And then when it comes to challenges and discoveries, we had a few, and one of them being supply chain, right? Supply chain was an issue because we wanted like we had a lot of critical parts that we wanted to order, but the issue was that it would take a really long time for them to actually arrive and for us to actually integrate it and put everything together. And so this really required us to do a lot of different things. For example, as for the wheels, as you guys saw in the last diagram, we were thinking about actually getting specific wheels for the device. However, because of how long it would take, we decided to use this thing called CNC, which is using a computer to numerically control a machine and using aluminum stock and make wheels for our device out of that, right? And then another example would be the belt. We were trying to get a custom-made belt from different vendors, but it would take extremely long for those belts to get here. And while it would save us time if it came on time, but the reality was that I think it was much better for us to actually do everything ourselves in this case because it really pushed our engineering skills and put it to the test. And so as for the belt, what we did was we used laser cutting, and what it did was it made specific patterns within the belt, as you can see here. And another challenge here is controls, because again, the motor that we had, extremely dangerous, extremely powerful, right? Ridiculously powerful. And so safety is a huge concern that we have, a huge priority that we took into consideration. And so making sure that we come up with a code that has very many different instances or scenarios and taking into account safety in each one of the scenarios was a huge thing. It required a lot of trial and error and a lot of testing. In the beginning stages, when we had the motor running, the only way to stop the motor and make sure like everything was good was disconnecting the motor from the battery. And so we came a long way, especially in trying to make sure that the controls are the way they should be, while making sure that they have the necessary features that we want, but that they're also safe. And so we were able to code the motor in such a way that it could be controlled by a remote controller, as seen over there. So you have 4 buttons, and so you could technically use 2 or 3 buttons to slow down the motor, to speed up the motor, and then the other 2 is like having a safe brake or safe slowdown of the motor, and the other one is just trying to hit a constant speed and just going from there. And some other challenges that we had with the treads is making sure that you get the specific pattern, and you're able to do that with the laser jet, but initially it was sort of overwhelming and concerning, like how should we go about this, especially since we were thinking about getting this from a vendor. And then another concern that we had was making sure that the belt does not slip. And so the way we tackled that was to add a tensioner onto the belt so that there could be more tension and then everything could be more put together. And then another obstacle we had was tight tolerances for integration, because everything had very tight, very small margins of error, so we could not mess up. And the way we went about this was by going into CAD a software online where we put the dimensions of every single part into and assemble everything within the CAD and making sure that we work on the dimensions that we have so that we do not make any errors, especially when it comes to integration or fabricating parts around those other components. And yeah, any questions?
So I was wondering, because to get the electric skis to work, you have to add, the motor and the belt you suggested and other components. Would these feel mostly like normal skis to an experienced cross-country skier, or where they have to get used to like giving an extra weight from the other components that allow the electric part to work?
I'm sorry, I didn't catch the last part.
So would these feel about the same weight as normal skis for an experienced skier, or would they have to adjust to the extra components being on there?
Yeah, no, that's a good question. There's a small additional weight in the back that the skier has to get used to. But when we tested it out, it wasn't that much of a big difference. If anything, everything seems normal, but what happens is it actually enhances your turning. So if anything, it provides more of a benefit, which was a lot interesting. We didn't really expect that. At first, we thought maybe it might be inconvenient for the user, especially when you have weight in the back, but the reality was that it actually helps with turning. So you also want to make sure it's not too bulky, right? Because if it's too bulky, then it's pretty hard to pick up and whatnot. But yeah.
Hi, I think your project's super interesting. I love skiing. I would be so excited to see this product on the market. I have a lot of questions, which I'll bring up to you later. But my main question is why did you limit the speed, since alpine and even experienced cross-country skiers can hit speeds well over 32 miles an hour? Are you aiming this product towards new or first-time skiers recreationally, or and just a second question to add on to that is, unfortunately, snow is never as nice, as uniform as you want it to be. How safe is your product with the possibility of kind of detritus, leaves, sticks, ice, stones getting into the inner workings of your treads and of your motors?
That's a good question. Let me start off with the second question, because we recently actually tested the device in different terrains, sand, ice. Those are two of the ones that we tested so far. We also tested on tiles. It turns out that the performance is pretty ideal. It's contrary to what we expected, because initially we thought that there may be some things that were going in and whatnot. But because of how we were able to enclose the device, and because of the way the tread system is designed, it's not really that much of an issue actually. Everything works pretty smooth, and the performance is the same, remarkably. And then going back to your initial question about whether or not the intended audience, right? If I remember that correctly. Yeah, and so the reason why you want to limit the speed at first is because we're in somewhat unknown territory in terms of in regards to the motor, because the motor is extremely powerful, and especially if you want to bring this out to the market, you got to take a lot of things into consideration, such as regulation, getting licensing approval and whatnot. And so we also, at the same time, again, you're in unknown territory. You want to make sure we play it safe for now, because as once you bring it out and have more people try it and see what the comfort levels of different people are, it may be better, because again, you want to make sure this is for recreational, right? Mainly, but it can also be a means of entertainment for more experienced skiers as well. Down the line, you may consider getting rid of the cap for more advanced or expert skiers. But for now, just for safety purposes and making it accessible to everyone, we want to be on the safe side. Hope that answers your question.
Yes, thank you very much.
All right, well, that's about all the time we have. So thank you for closing out the day, Waleed.
Thank you.